Let's return to our two very useful coupling reagents, NHS ester and maleimide, and let's look at their use in a practical nanoscience application. In chapter 4, we talked about functionalizing a microscope probe so that it had an antibody at the end and could recognize single molecule targets. Exactly how do we go about this? Well, the first step is to take an atomic force microscope probe, which to first approximation is just a very dirty surface, and expose it to an oxygen plasma, which is highly reactive and oxidizes organic materials on the surface of the probe, leaving behind a freshly oxidized silicon surface, if these probes are made of silicon, which most of them are, or a silicon compound. And silicon at its surface is oxidized to silicon dioxide. So let's just show the inside of the silicon here. And so on. And the surface has on it hydroxyl groups once it's been cleaned. We use a reagent called aminopropyl triethoxysilane. So let's draw this up. This is the chemist way of showing a chain of 1, 2, 3 carbon atoms attached to a silicon, and then here an amine group, NH2. Remember, this is the thing that the NHS ester grabs a hold of. And then this has stuck out on its side via a couple of oxygen atoms, C2H5, C2H5, and then for the fourth valence position of the silicon, another OH group. This OH group is highly reactive, particularly in the presence of water. So one has to be careful using this reagent. It needs to be carefully dried. But once it sees another OH group on the surface of silicon, it will react to form H2O and leave behind a bond O to the aptes, which I'm just going to call this. And then here is that exposed NH2 residue on the surface. So by exposing this cleaned probe to this reagent aminopropyl triethoxysilane, one can place primary amines on the surface. So that's the first step. So now one has a probe that one might draw schematically like this. And so one can purchase flexible linkers, which are polyethylene glycol. That's a polymer that looks like this, where once again these things are carbon atoms. So this here is the repeat unit of it. So let's just draw our carbon atoms and more oxygens. So on. It's a soluble polymer because of this oxygen in the backbone, and it's highly flexible, called polyethylene glycol. One can buy this, and I'm just going to draw it as a squiggle now, with an NHS ester at one end and a maleimide at the other. So this can be coupled to the probe. At this end, the maleimide can be used for coupling to whatever is desired, in our case an antibody. And so what is done is to treat the antibody with a thiolating agent, which similar to the NHS ester, couples sulfurs wherever there are amines on the protein. These are then reacted with the maleimide, so now one has a PEG and an antibody attached to it with an NHS ester at the top. A solution of this sort is brought in contact with this aminated probe, and the final result is the structure you saw drawn schematically, a probe with an antibody attached to it.